Today we're going to look at hyperbolas, and this is a pretty complicated conic section with a lot going on. So I am going to make a video so that you can watch it more than once, and because some people are absent. So that's why I'm making a video. So to get started, first of all, a little joke. What do you call a snake after it drinks 3 cups of coffee? And the answer is a hyperboa. Get it? Ha ha ha. Okay, so now on to this. So for our notes, we are going to first write the equation down. And here we have x minus h squared minus y minus k squared, and then it's going to equal 1. And over underneath the x we have a squared, and underneath the y we have b squared. So in this case, when we had ellipses, a was always the bigger number, and in this case a is always the first number. So you look and see what is first and what is second. And so in this case x is first, and so a is under the x, so it's a horizontal hyperbola. The distance from the center to the vertex is a, and we call that the transverse axis. That's a new vocabulary word, transverse axis. The distance from the center, see, it kind of makes this little box. Do you see that little box? From the center up is b, and I'll make more sense in a minute when we graph the asymptotes, the slopes of these lines, but that is called the conjugate axis. Okay, so we have a and b just like before, except instead of making an ellipse, now we're making a hyperbola. Okay, those dashed lines are called asymptotes, and we've done those before. The slope of the asymptote is m equals plus or minus b over a. Okay, m equals plus or minus b over a. So that's how you know if you go up b over a to the right, or up b over a to the left. Okay, we still have foci, and in this case it's the square root of a squared plus b squared instead of the square root of a squared minus b squared. So for an ellipse, the equation is add and the foci is subtract, and for a hyperbola, the equation is subtract and the foci is add. Okay, on the other side, for a vertical, everything is pretty much the same except just switch. So instead of x coming first in the equation, we have y coming first in the equation. So we still have a as the center to the vertex, and b is the center on the side, going out to the side, and it's the conjugate and the transverse axis again. In this case, the slope of the asymptotes is plus or minus a over b. Remember, it's rise over run, so up and over. And the foci in this case is still a squared plus b squared. So a is first, a is not always bigger. Once again, a is first, not always bigger. So in this case, that is what we have. So a is first, not always bigger. A little bit different from before. Okay, so for this first one we're going to look at, we have a vertical hyperbola, and I know it's vertical because y is first. Okay, the center point is -2, 1, and remember it's a little backwards because you have to look at the x and then the y. A is 7, b is 5. Now the next thing that it asks us to do is to graph the asymptotes by using the slope. So because this is vertical, I know that I'm going to do a over b. So up 7 over 5, up 7, down 5, up 7 left, down 7 right, all the ways to write a line. So if you see the yellow, I am writing the slope. So I went up 7 over 5, to the left and to the right, down 7 over 5. And that is where I know to draw my hyperbola. So the teal I just drew is the actual hyperbola. The yellow is the asymptotes. Okay. Next I'm going to find the foci using the equation, the square root of a squared plus b squared. And that's the square root of 49 plus 25, which is the square root of 74. So my foci are -2, 1 plus or minus the square root of 74, and then I can draw those in if I would like. Okay, so that's how to graph it. Now for the next thing, we are going to go through and talk about where each the different options, okay? Because for a horizontal, for an ellipse, you can have only a vertical and a horizontal. And if it's vertical, it's tall and skinny, and if it's horizontal, it's short and fat. However, for a hyperbola, when you have vertical, you can still have a short and fat or a tall and skinny. And what I mean is that since A is not always bigger, A is just first, we have two options. We have where A is bigger and then where B is bigger. Okay? So in this case, it's a vertical because Y is first. And if I draw the asymptotes, and these are just quick sketches, and y'all can pause it in a minute, but I just want to show you the options. So see how that's a tall and skinny hyperbola that's vertical. However, let's have that same equation, but switch the 4 and the 36. So it's still vertical because Y is still first, guys, but instead, now the slope, instead of being 3, the slope is 1/3. So now it's going to be a short, fat hyperbola instead of a tall, skinny hyperbola. See how it's short and fat, and there's the hyperbola. Okay, so notice those are both vertical, but Y comes first in both of them, but the A and the B are switched. Okay, now we're going to do the same option with horizontal. A can be A can be bigger, or B can be bigger. Okay, if A is bigger, X would still come first because now it's horizontal. So the slope of my lines now is B over A. So up 2 over 6. So this is going to make a horizontal hyperbola. Okay, but the box is still long and short and fat. The slope is 1/3. Now if I do that same equation but switch the 4 and the 36 again, okay, now it's going to make a tall skinny box, but it's still a horizontal hyperbola. So they're still going off to the sides. Okay, so like I said, pause the video if you need to jot these notes down, but I just wanted to show you that there's now 4 kind of options. For an ellipse there's really only 2, but for hyperbola, because it can be tall and skinny or short and fat, there's 4 different ways that you might see these equations. Okay, so hold on. Let's look at this next few examples. Okay, so for this first one, we need to first write it into into the correct form where it equals 1, and we've already done this in our notes the other day, except now it's just subtract. So the center is at 0, 0, and I know that because nothing is being added or subtracted from the x and the y. There's no h and k. And then what I'm going to do is go over and put my center dot at 0, 0. Now I know that a is 2 and b is 5. So for my asymptotes, I am going to go, since this is a horizontal, I'm going to go up 5 over 2. Up 5 over 2, down 5 over 2, down 5 over 2. And once I've done that, I can graph my hyperbola. Okay, so see what I did there, guys. I went up and over based on the asymptotes, and then I graphed the hyperbola based on the vertices that I found from using A. Okay, then I can find the foci. It's not a huge deal. Square root of 25 plus 4 is the square root of 29. The transverse axis is 4 units long, the conjugate axis is 10 units long. Notice with the conjugate and the transverse axis, one's not always bigger than the other. You know, before we had major and minor because major was always bigger. But because these don't have to always be bigger, transverse could be bigger, conjugate could be bigger. The difference is transverse is from vertice to vertice. Okay, transverse is from vertice to vertice. I can list the vertices. The slope is 5 over 2. Domain and range. Okay, domain goes from negative infinity to 2 because it stops at negative 2. Then it picks up again at positive 2 and goes on to infinity. Okay, we should be able to do these without much problem. Okay, right now would probably be a good time to pause the video, try number 2 on your own, and then unpause. Okay, so I'm going to go through it fairly quickly, so try it first, and then unpause the video and go from there. Okay, hopefully you've given this a shot, and now you're ready to watch. So A is 2, B is 3. I start by drawing my center and the vertices, and then the asymptotes. Okay, so in this case, I'm going to go up 2 and over 3, down 2 and over 3. Okay, draw the asymptotes, draw the function, find the foci. In this case, it's the square root of 13. So I know that I'm going to do it to the y because I'm vertical, so up and down. Transverse axis is 4, conjugate is 6, vertices are pretty easy to find. Slope of the asymptotes plus or minus 2/3. Domain in this case is negative infinity to infinity. Range negative infinity to -3, and 1 to infinity. And notice those are the points on the vertices. Okay, next one, same thing. I'm just gonna, hopefully you've already paused the video and tried number 3. Now you can watch it. The center is at -1, 2. And A is 3, B is 2. This is vertical because Y comes first. So draw the center, draw the asymptotes, up 3/2, down 3/2, to the left and to the right. Draw the function, find the foci, then answer the rest of the questions. So I am going to stop the video here because we've already gotten to about 11 minutes. And the answers to the rest of the homework will be posted on Edmodo. I will probably also make another video if I have time today. And so you can see the answers to the rest of this. But give them a shot. And like I said, you'll probably be able to watch in the video to see how the rest of these work. But like, this is the toughest one, and the notes are pretty long. And if you can do up through where we are right now, plus being able to write an equation, then you're really good to go. So give it a shot. Let me know if you have questions.